Hello all, welcome to the channel Mentor Talks. So in today's session, we are going to discuss about a topic that is linear programming problems. So inside this topic, we'll be trying to understand how we are going to deal with various kind of objective functions and how do you optimize them. So before we go into the topic, I just want to give an introduction about the topic, that is what is linear programming problems or where do we use these LPP problems. See, this is one topic which has got extensive application across various industrial domains as well as academic domains. So that is something which we need to remember. See, industrial domains means we'll be using this LPP to identify or to solve the problems on the basis of transportation, allocation, product mix. So those are the industrial applications. Whereas if you consider the academic point of view, this is a one topic which is being learned by MBA students in operation management. It is there for BSc and MSc mathematical students. It is also there for even for the +2 students also. They are also learning LPP. So it's very crucial that we should have a proper idea regarding this topic so that we could solve the questions and we could make some industrial applications. So let's try to know what is LPP. So LPP means it is the abbreviated form of linear programming problems. So what we are trying to do here is we'll be having a lot of objective functions. That means certain functions which include certain variables. And your idea or your objective is to optimize those functions. Optimize in the sense you need to increase the efficiency of those functions. I will make it a little more clear. Suppose the objective function which we are dealing here is a profit function. So you'll be having a profit function which would be made up of certain variables, and these variables would represent certain parameters which would influence the profit of your company. Now as a trader or as a businessman, your idea is to maximize your profit. So how do you allocate your resources properly so that you could maximize your profit? So in that case, I could use an LPP problem or an LPP tool for solving that situation. So that is a one case of optimization. Suppose we are talking about another case where your objective function is a cost function. Cost function in the sense, in this case, your function would be containing certain variables or certain parameters which would be acting as the influencers of the cost, influences of causing the cost in that your company. So now when you get a cost function, in that case, your idea or your objective is to minimize the cost. So it is a minimization function. So LPP in general, we can say that it would be always having an objective function, and this objective function would be made up of certain variables. And each of these variables would represent those parameters which would influence your objective function. And your idea or your ultimate aim is to optimize that function. That means you need to maximize or minimize your objective function according to the requirement of the question. So this is what we do here on LPP. Now, as I was saying that it has got extensive application, we could use this in making a decision of transportation decisions. We could use in making allocation of resources. We could use in designing the product mix. So everywhere we could apply this. All right. So before we go into a lot of theory regarding this one, I would love to show you an example. With the help of example, you'll be able to understand how do you define an objective function, what is a constraint, and how we can use LPP. All right. So let's go for an example. So we would just take a small example. So that will help you understand all these things. All right, listen here. So what we can see is we can just consider a small furniture trader. Okay, so we got a trader. With the help of this example, we would understand what is being happening here. So let's say we got a trader. Okay. Now the specialty of this trader is he's actually dealing on different types of furnitures. He's mainly dealing on only two types of furnitures, that is tables and chairs. Okay, so this trader is dealing on tables and chairs. This is something which we need to understand. Okay, so here we need to see like what is the cost of each of the table and how much money he has got. All those things has to be considered. So imagine this furniture trader has got a maximum amount of investment as rupees 50,000. That is something which we need to know. So his investment or his capital is rupees 50,000. So he cannot invest more than that. That is the maximum amount which he is having, rupees 50,000. That is his capital. All right. Now you should know that he has got a godown or a warehouse is there where he buys these things and stores, and there is a maximum storage capacity, or there is a maximum space capacity for that warehouse. That space capacity, that is the next constraint or next point which is being mentioned here, that is 60 items. So at a time we could store only 60 items in his warehouse. Alright, so these are the first initial inputs which is being given on the question. We have a furniture trader who actually buys these tables and chairs, he stores it on his warehouse, and at the right time comes, when the right time comes, he would just sell them and make profit. That is the idea. And we know that right now he's having a capital of rupees 50,000 only. That is the maximum amount which he have. And his warehouse space, his warehouse could accommodate maximum of 60 items at a time. So all these things you can see or you can consider as the inputs. Now we need to see two more things. The next thing is the cost function, or the cost we need to understand. So at what price he is buying, that is the cost thing. That means how much he is incurring. Now imagine he is paying something around 2,500 rupees. Alright, I'll just write it again. So the cost of one table costs rupees 2,500. That is the cost of one table. And similarly, if you consider one chair would cost say rupees 500. So this is the cost. Alright. And we also need to know what is the profit which is being obtained by him when he makes a sale. So when he sells this chair or table to a third person, what is the amount of profit he gets out of this? So when he sells one table, he would be making say a profit of rupees 250. So 250 rupees is the profit made from selling one chair and from one table. And from selling one chair, imagine he makes a profit of rupees 75. Now, so a lot of information is given about this particular furniture trader. Now, what is your idea is based on these informations, we need to frame your objective functions, need to frame your constraints, and then we will be actually trying or using LPP to solve this particular condition. Now, the question is like, we know all this information. We need to find what is the right combination, or we need to identify what is a optimum combination of number of tables and chairs that would yield him maximum profit. So as a trader, he need to find the exact number of tables and chairs, or what is the adequate number of tables and chairs that he should buy so that he could make maximum profit out of this situation. That is what we are going to do in this case. I hope you have understood what we are trying to do. So from this furniture trader's point of view, he need to buy maximum number of tables and chairs by keeping the point that he has to make the perfect combination of number of tables and chairs so that he would yield maximum profit. That's what we want to do. So here, first thing is we need to write our objective function. This is very elementary thing, so pay attention. So let's write our objective function. So objective function means this is a function which we are trying to optimize. Or in simple terms, this is a function which we are trying to maximize or minimize. Am I right? So here, the first thing which we need to do is, we need to see that how many number of tables and chairs we are dealing. That is a question which they are asking. So we will just make an assumption for making these equations, because as I was telling you, your objective functions, that is always based on certain variables, and those variables represents the parameters which are influencing that objective function. So here those parameters which are influencing your objective function, they are the number of tables and number of chairs. So let's start an assumption with your number of tables and number of chairs. So we'll start by assuming the number of chairs. So let the number of chairs, the number of chairs he is dealing is X. Okay. And the number of tables he is dealing, that we can take as Y. So this is your assumption. Now based on this assumption only we can start. Now, so X is a variable which represents number of tables, and Y is a variable which represents number of chairs. Now I need to form the objective function based on this variables x and y. So naturally you'll be having a doubt what is objective function. So objective function is a maximizing or minimizing function. In this case, our objective is to maximize profit. So profit is the objective function. Alright, so let's write our objective function. Okay, I'll just go a little higher. Okay. So here in this case, what you can see that your profit is objective function. So let's write profit, objective function. Normally objective function is represented by the letter Z. If you want, you can use P itself, not an issue. So I'm writing P only. So what is his objective? He need to maximize the profit. And how he is making profit? He is making profit by selling tables and chairs. And we know that the profit he makes from selling one table is rupees 250, and the profit he makes from selling one chair is rupees 75. So he sells like number of tables which he sells is y, and the number of chairs which he sells is x. So in that case, what we can understand is the profit made out of selling the tables. One table cost, or the profit from one table is 250. Like that, y tables are there. So I can write it as 250y. 250 into y. So this is the total profit made out of selling the tables. Similarly, one chair costs rupees 75. Like that, we got x number of chairs. So the total the total profit obtained by selling the chairs is 75 into x. So 250y plus 75x. This is your objective function or your profit function. And our idea is we need to maximize this function. I hope you are getting. Because when you get a question, you have to read the statements which is given on the question. And from that, you need to frame your objective function by yourself. So in this question, your objective is to maximize the profit. So what we have done is, we have taken the profit which was obtained from the table, that is 250 is the profit from one table, like that. Y tables are there, so 250y plus 75 is the profit from one chair, like that we got 75x. So this is how you write your objective function. Okay, so now that part is over, but this is not completely over. Now when he want to buy these tables and chairs, he has got certain constraints, or he has got certain restrictions. So now we need to consider those restrictions, and that would be written as the constraints. So that is the next part. So let's see what are the constraints which he need to face. We'll just look into that. Okay. Now once you write your objective function, the next part is you're supposed to write the constraints which are there. So we'll see what are the constraints which is being discussed. Now listen here. The first constraint which we need to talk about here is like there is a capital constraint, or there is an investment constraint, or simply we can say that there is a money constraint is there. He has got a total capital of rupees 50,000 only. So whatever is the number of chairs and tables he is buying, he will be able to spend maximum rupees 50,000 only. He cannot spend more than 50,000 rupees because that's what he got. So that's what we call the first constraint, that is a money constraint, or simply we can say it is a maximum amount of money which he could spend as an investment. So how do you write this money constraint as a linear equations or inequation? That is the next part. Now here, if you look into this thing, we know that one table costs 2,500 and one chair costs rupees 500. Am I right? So here what you can understand is the cost of one table is 2,500. Like that, imagine we are buying white tables. And the cost of one chair is 500. And like that, we are buying 500 chairs. So the money which he has to spend in this case. Okay, so the money which he has to spend in this case. So that I'll write here. Just give me a second. Okay, fine. So the money which he has to spend in this case is like 2,500 into y. This is the money which he spends on buying tables, plus 500 into x. That is the money which he spends on buying, chairs. So this is the total amount which he spends or which he spends as his investment, we know that the maximum amount he could invest is like 50,000 only. So 2,500y plus 500x should be either equal to 50,000 or it should be less than 50,000. Because when he makes the investment, if he want, he could invest the whole money which he got, or he wants, he can invest the money which is less than what he got. So this as an equation, if I write, this should be less than or equal to 50,000. I hope this is clear for you. This is your first constraint. So what you have written here, it is nothing but this is what we call as a money constraint. That means we have a condition. So practically speaking, what we do is when we are trying to solve this problem, what is the problem or what are the restrictions faced by the trader? Those restrictions could be written as inequations, linear inequations. That's what we have done. So the maximum amount which he could invest is 50,000. So 2,500x plus 500, 2,500y plus 500x should be less than or equal to 50,000. Okay, this is what we call as money constraint. So one constraint is over. Now we have to consider the other constraints also. What is the next constraint which is coming here? If you observe here, there is something which you call as space capacity is there. That means at a time his warehouse could accommodate a maximum of 60 items only. That is, inside the warehouse you cannot store more than 60 items at the same time. So there comes the next constraint. This constraint we can call it as space constraint. Are you getting that? So here the number of chairs and number of tables, the total number of chairs and total number of tables should not exceed 60 items. That means maximum I could store 60 items or I could store less number of items than 60. So that should be written as your next constraint. So how do I write? Number of chairs and number of tables. So the total number of chairs and total number of tables that I can write as x plus y. Okay, this should be either less than or equal to 60. So that is your second constraint. Okay, so this constraint we can call it as space constraint. See, normally when we solve the questions, we won't write these things like money constraint, space constraint. We won't name them. I'm just writing here so that you would understand that. Okay, so this is the second type of constraint which you can call as a space constraint. So we have just written two constraints. The first one is a money constraint and the second one is a space constraint. Now the other thing which we need to understand here is like he would buy. We know that number of chairs and number of tables are represented by x and y. So x is the number of chairs he is buying and y is the number of tables he is buying. We know that if I want, I can buy 0 chair. Number of chairs which I can draw is which I can buy is 0 chairs, but I could never buy negative number of chairs. Similarly, I cannot buy the negative number of tables also. So you should understand that here x and y will not be negative. Are you getting that? So x would be any value which is either equal to 0 or greater than 0. And similarly, y is any value which is either equal to 0 or greater than 0. So that also has to be written. The reason is very simple. Since we are dealing with the number of articles, or since we are dealing with the articles like chairs and tables, the number of chairs and number of tables would be never negative. Minimum value would be 0. So that even that could be written as a condition. That means x value should be greater than or equal to 0. That is, a minimum value of x is 0. Similarly, y should be greater than or equal to 0s. This x is greater than or equal to 0, y is greater than or equal to 0. We call it as non-negative constraints. We can call it as non-negative constraints. Okay. So that's all. This is how you write this question. If you get a question like this, this is how you represent them as objective functions and constraints. Once you write like this, that means once you have written your objective functions and constraints, how do you solve this? That will be discussed on the coming lecture. So again, I am just going to quickly go through the entire question one more time so that you will understand that. Alright. So we'll see here. So in this question, what we are discussing is there is a trader, furniture trader, and what he does is he is dealing on tables and chairs. So he buys some tables and chairs, he stores it on his warehouse, and then he sells it to make some profit. and he has got two types of constraints. That is, the maximum amount he could invest is like 50,000, and at a time his warehouse could accommodate a maximum of 60 items only. Now again some more data are given, like the cost of table and chair is given, and also the profit which is being obtained by selling this chairs and table is also given. So based on this information, you need to frame your objective function and your constraints. Then only we can use LPP. So here objective function is like profit. We need to maximize the profit. So that you can write this way. So like profit from one table is 2,250 and one chair is 775. So 250 into Y, that is a profit from all tables, plus 75 into X. So that will give you the profit function which you can maximize. Now we need to consider the restrictions on which this objective function has to be maximized. We call them as constraint. The first one is there is a money constraint. The maximum amount he could invest is 50,000 only. So the cost function 2500y plus 500x, that should be less than or equal to 50,000. We have space constraint also coming. So that is x plus y less than or equal to 60. And of course, the number of chairs and number of tables will be never be negative. So in that case, I can write them as x greater than or equal to 0, y greater than or equal to 0. So this is how you consider, this is the first part of your LPP problem. So when you get an LPP problem, after reading all these things, you're supposed to write your objective function and constraint. I hope this is clear for you. Okay, and here I have clearly explained what is the objective function and constraints. So let's see some more problems that would give me a little more idea about the same thing. All right.